Now let's just move on further towards the new topic, which is nothing but called as some properties of a triangle. And in this particular topic, we will discuss some of the important other criterias of the congruence as well. So let us suppose if we are just starting with the very first theorem, which is related with some properties of a triangle, which says that the angles opposite to the equal sides of an isosceles triangle are equal. So it means we have to show that the angles which are opposite to the equal sides of an isosceles triangle, they are equal. So I hope you all are already aware about the isosceles triangle. So isosceles triangle is a triangle in which it do have two sides equal. So let us suppose if I'm just taking this isosceles triangle, so neglect this AD part first. I am just taking the isosceles triangle ABC, and here I have done a little bit of construction in which I have drawn an angle bisector of the vertex A, and this is intersecting BC at any particular point D. So this is actually an angle bisector that I have drawn for the construction in order to prove this particular theorem. So let us suppose if I'm just starting with the given condition and what we have to prove. So let us suppose if I'm just starting the given condition. The given is nothing but an isosceles triangle ABC, an isosceles triangle ABC, such that AB is nothing but is equal to AC. So this is nothing but a given condition to us in which it is nothing but an isosceles triangle with the equal side as AB is equal to AC. Now let's just move on further with the construction. So draw. In the construction, we have to draw an angle bisector. Draw an angle bisector of angle A such that it bisects, it intersects BC at D. So now let's just write what we have to prove. We have to prove that the angle B is equal to the angle C. So according to the condition, according to the theorem, we have to prove that the angle opposite to the equal side means this is the angle and this is the angle which is opposite to the equal side. So we have to prove that this angle is equal to this angle. So let us suppose if I'm just starting with the proof of this particular theorem. So first of all, as you can see over here that we have drawn an angle bisector. So if we are just drawing an angle bisector, it means that this particular angle and this angle is equal to each other. So let us suppose if I'm just writing it as angle 1, I'm writing it as angle 2. So it means that angle 1 should be definitely is equal to the angle 2. Now furthermore, let us suppose if I'm just taking it as angle 3, I'm just taking it as angle 4. So let us suppose if I'm just talking about the two triangles, that in triangle BAD and triangle CAD, first of all, angle 1 is equal to the angle 2 by construction. We can say by construction we know that these are equal to each other. Furthermore, we know that AB is equal to AC. So AB is equal to AC. It is already given to us. And furthermore, we can see over here that AD is equal to AD is nothing but a common arm. It is nothing but a common side or a common arm. So what can we say about these three conditions? Let us suppose if I'm just writing it as 1, 2 and 3. So here we are getting two sides and one angle that is enclosed or included in between the two sides. So this side and this angle. So it means that we are just talking about the congruence criteria, that is SAS, side angle side criteria. So as per the SAS congruence, it implies that the triangle BAD is actually congruent to the triangle CAD by SAS congruence criteria. So if the two triangles are congruent to each other, what does it imply? It implies that their corresponding angles or the sides or the corresponding parts are actually equal to each other. So hence this included angle, or we can say that this angle is lying in between this particular triangle and this angle is lying in between this particular triangle. So it implies that angle 3 should be is equal to the angle 4. So it implies angle 3 should be is equal to the angle 4, and angle 3 is actually nothing but the angle B, which is nothing but coming out to be is equal to the angle C. So this is what we wanted to prove over here. So hence it is proved that angles opposite to the equal sides of an isosceles triangle are nothing but equal to each other. So this is nothing but all about this theorem.